Hey there, I'm Chroma, and welcome to another Unity development log progress video thing. Now, this is an interesting project that we're looking at today, a thing I've been making over the last little bit. Editor madness. This isn't a game per se, but it kind of is. It's something that only works inside of the Unity editor because it takes, it uses a lot of functionality of custom editor type things. The whole point of this project was to learn custom editor things. So custom editor scripts, custom editor windows, property drawers, scriptable objects, and a lot of that kind of interesting things that you can do in Unity to change the functionality of how the editor works. So it's pretty neat stuff, and I used a lot of my learning in that to make a game per se. So the first thing we're going to do is run through the game, and then I'm going to go and explain how I made it, because I think it's interesting to for me to showcase how I went about making things, the problems that I faced while doing so, and all of that sort of stuff. So to start, let's play. So the main premise of this game, actually, I guess I'll just start by reading a little introduction here that gives the gist of what the game is. So, welcome to Editor Madness. Solve the editor puzzles and work through each level. If you're stuck, use the above buttons to skip through levels. So, start by solving the hardest puzzle of all, clicking the button. And then we got a button that's, can you click me? So, to start off is that this is inside a custom editor window. So I can close this and you'd be looking at something like this with your default scene thing. I have the console docked behind my head so you can see the inspector better. In fact, I can put it more like that. Yeah, so if you go to custom editor window, or custom editor madness, this opens up the window, and this actually, opening this window resets the whole game. So that's a nice thing there. Now my way of playing this is just by having the components that you need open, the windows you need open, is just the editor window just somewhere, and the game view. Usually three things on screen: the editor, the game view, and the inspector. So this format works for that. So to start off, we got this spinning text here. Welcome to Editor Madness. Yeah, it goes off screen. I just thought it was funny to have this text spin. And it has a random background to it, and it has my little logo there. So the first thing I'm going to do before we go through the levels, I just want to kind of skip through and just go blam, 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 blam. This level's really cool. Blam. So this is just a look forward at what we're about to go through. This one I think is the coolest. We'll get to that in due time, just so you can see what we're going through. So yeah, this level select at the top is the just to skip through the levels. I could have done like unlocking levels or whatever, but no, that is fine. I say like you can go through them if they're stuck. Like you can use them if you're stuck, but these aren't really puzzles. It's just kind of instructions for the sake of making use of a lot of interesting custom editor things. So let's go through this. So the starting thing is just click the button. Ta-da! Solved level 1. Now level 2, do the hardest math questions of your life. So we got 2 plus 2, 4. Wow, cool check mark. 7 minus 10. Oh no, what is it? 3. Negative 3. And then complicated math thing that is 0. Bam. When you solve all the questions, continue button. Continue. Level 3, move the slider to the correct position. Hint, watch the game view. So if you're only looking at the editor at this point, you need the game view now to actually be able to solve this puzzle. So you have this slider here, and it actually moves this cube, which is pretty neat. And now there's this arrow here. You basically want to move the cube to where the arrow is, and there's the continue button. Continue. Next, we got win a game of tic-tac-toe, place the X. So we got this is also a tricky level to, not too tricky to set up, but do some like bug fixing. But we'll get into that in due time. So we got this tic-tac-toe board. You're placing the X. Do you place it here? Oh no, that's not right. How about here? Oh no, that's not right either. These other ones, I can't place it there. This one, bam, it's working. Cool. Or like now we got into tic-tac-toe thing. Yeah, woo. Continue. So do that. Level 5 was easily the hardest level to do, only because of some design choices I made on purpose that if I didn't do, it would have been a lot easier, but we'll get to that in due time. So yeah, level 5, I'm thinking a number between 1 and 10. Can you guess what it is? We got an enum thing here. Is the number 9? Nope, wrong. Guess again. Is it 1? Nope, it's not good. Is it 6? Whatever. No. 3, that's correct number. Cool. Continue. Level 6, turn on all the green lights and turn off all the red lights. So this, we got some toggle switches that are turning on and off lights that are them being rectangular like this was accidental, but I went with it because it looks cool. So you're basically trying to, it's almost like finding the password kind of a thing. So you just kind of go through and have the red ones on, the green ones, red ones off, green ones on. And then once you have the correct password sort of thing, then ta-da, we can continue. Level 7, copy this text, hello world. So let's do that. Just this. Now actually I did this on purpose to make it slightly easier, is that capitals don't matter. So if I typed it all lowercase or all capitals, it'll still accept it. Just kind of a thing to make it slightly better. And that once you do it, then it appears over there, which I think this is quite cool. And then continue. There we go. This level looks quite cool visually. Got this interesting thing of colors. Make all the buttons green. So if you click on these buttons, they cycle between red, then green, then blue. And yeah, you just got to go through and make them all green. And that is then being replicated over here with these are a bunch of cubes that are also changing their colors. And again, let me also reiterate, you notice how I didn't go into play mode. All of this functionality is happening in the editor without going into play mode. So that's the other really cool part of this, is just getting that to happen and work successfully. Because a lot of things that then you can't really do, they kind of do manually in order to be able to do this stuff without going into play mode. Like physics stuff is a big thing. Yeah, so next we got level 9, move the monkey to the outline. So we got the good old Suzanne monkey from Blender. Yeah. Before I move things, explain what's happening here. So when you go into this scene, then the inspector view now is showing the wireframe, so you can see the transform of it. And effectively, moving this position rotation scale is moving the blue monkey, and so you can see that. And you're trying to move the monkey to match the outline. So because you can see the wireframe version of it here, you can just type in the transform values. So I should do that real quickly, and then you can see it's slowly being in the right place step by step, and then once it's perfectly matched, then we can continue. Woo. There's also a thing here that where the numbers when you're typing them in, they round to the nearest 0.5 for the position, the nearest tenth, like the nearest 10 degrees for the rotation, and then the nearest 0.5 for the scale as well. So just another thing that makes it easier to, if you weren't looking at the inspector, you were kind of guessing and checking with the numbers, just makes it a little bit easier to have it snap to the correct position. Cool. So now then continue, and then the last challenge, perhaps the hardest of them all, use the directional buttons to guide the cube to the end of the maze. So here we got a maze, and as a part of this, we have an actual maze game through clicking these buttons, which I think is quite cool. This might say my favorite level, but it wasn't the hardest to make, surprisingly enough. I'd say second hardest, but the hardest was the property drawers, or the level 5 with the numbers. So the guessing a number between 1 and 10, that one. And we'll get into why when we get into it. So guiding the cube through this maze, it's basically got custom collision detection pretty much, which is cool. So yeah, pretty neat. And you go towards the end, you're not clipping through the walls, and just the fact that the cube is moving despite being in, again, we're not going into play mode, and it's doing this collision detection without I can't use proper intersections of colliders necessarily, because it doesn't work that way. But anyways, we get to the end, and ta-da! Then we can continue, and now we've reached the end. You did it. Congratulations. You mastered editor madness. Feel free to go back through the levels. So, ta-da! Then that is the end. And this is my, some stuff with my, branding, social media stuff. That has my little animated me here. Lab coat and all. And we got this thanks for playing text that is also, it's moving back and forth, which is cool. And that's actually, spoilers for ahead, I guess, but it's moving through a sine wave. So some interesting math there. And then also now we can reset to go back to the beginning. So this is another thing that resets the whole game. So that is Editor Madness in a nutshell. And now we're going to go through all the code. And I think the best way to do that is to probably just go from level 1 all the way down. Now, first I'm gonna go over the kind of framework of how the level, how I'm able to have different levels. And this actually isn't changing scenes. Actually, in hindsight, I'm realizing that I maybe could have done that to change scenes to go between the levels, but no, it's all in one scene. So going to the hierarchy and the progress, the hierarchy and the project view. I'm gonna go into the scene view as well. The basic structure here is, so we got the camera and the directional light. This we'll get into later. This is to do with actually the intro text, or all the long text being localized in one place. And yeah, so in we got an empty game object here. We got an empty game object here, levels, and under here we have all of our levels. And essentially these are just the sort of collection of game objects for each level. So we got the level 1 here. If I were to turn this off and then turn level 6 on per se, that's all the lights. Which actually you can see here, like only from a top-down view, these draw halos become square. So this was accidental, but it looks cool, so I left it like that. And then we got like level 10, that is the maze. So that's how the level thing is being done. Going back to just level 1 real quick. And then under here is just all the objects that have to do with that particular level. So essentially the custom window is, depending on what level we're on, it's just, all it really is doing is just deactivating and activating these empty game objects. So that's how that organization is being done. Yeah, so then I guess now is probably a good time as ever to go through the editor, or so the assets, like what assets we got in our scene. I'll just quickly gloss over these, and then I'll be going over the actual ones more in detail when we get there. Like going over what assets are being used for what levels when we actually get there. So here we got the editor scripts, and this is used for basically everything that these are scripts that have to do with the custom editor functionalities. We got this really, really long one. This is where most of the magic is happening. We'll be going through that a lot here today. We got this thing for level 5 with the number guessing thing, and we got a thing that has to do with the X's and O's of the tic-tac-toe board, but we'll be getting into those. Under materials, first I just made, I have just a bunch of materials for every like color, as I was coloring things, just named by their color, so just structuring it that way, including a transparent one for, I believe that's for the goal of the maze. And then we got a thing under here where this is a bit of a quirk with, because it's all happening in the editor, where on level 7, maybe, the one where there was all the colored cubes, each one has to have its own material, even though they kind of do the same thing, just because it's all happening in the editor. If it was in play mode, then they could all share a material and then just change their like instance colors, but yeah, we'll get to that when we get there. So then models, the only models we're really using in this scene, or this project, are the Suzanne model, the O of a tic-tac-toe thing, the X is just 2 rectangles, and then the wireframe Suzanne, that is the where you're trying to move the monkey. So that's that, and I didn't make the monkey. That again is in Blender and maybe some other 3D modeling software, I'm not sure, but it's just an example of like a higher, not so primitive model that just exists in the program. So that's that. Yeah, so then we got prefabs. The only prefabs that we're concerned with in this project are an instance of the O and an instance of the X, really. In scenes, we just got the main scene here. Scriptable objects. This is a thing we'll be getting into very, very shortly, but effectively the very general version of what this is doing is just storing in one place all of the long text in the editor window, just so I can have all this text be in one place for easy editing, I guess. Yep, so that's that. Oh, this doesn't enter when it maybe shouldn't, but oh well, that's fine. Doesn't really matter. Okay, so next we got scripts. These are the non-editor related scripts. Now, technically, because this whole thing is an editor game, like all of these could have maybe been in the editor thing, but I tried to still have that differentiation of like, these scripts don't actually do custom editor things, so they're just normal scripts. These ones do custom editor things, so that's, yeah. So we got that long text storage, we got this number guessing thing. There's something for the number guessing that we'll get into. Scriptable object access, that has to do with the tic-tac-toe board, and this one also has to do with the tic-tac-toe board. So, actually, no, this one has to do with the text. We'll get into that, as I've said. Next, we got sprites. The only sprites that are being used in this project, most of which were just grabbed off of Google Images, basically. So we got this check mark. We got my logo, the thing you saw at the end of just another, like, one of my kind of profile picture banner things. We got for the Hello World level. I think, no, that one's level 7, I think. The typing in Hello World, we got just a picture of it with the text and without. Where actually all I did to make this, and just jumping ahead a little bit, is just that I found this image off Google Images and then basically just cut out the Hello World and then put a box that was, or basically, paint bucket tool filled the hole with the background color. So just, that's how I made that. A random intro background thing that looked cool, the math background and the numbers background. So that's just, making it look a bit fancier, I suppose. All right, so that's all the different assets. We'll now go into more of them more in depth. So let me do that. Nothing should have been having to be saved there. Oh, from me, that was from me turning on and off levels. All right, so now let's go back to game view and editor madness window, and let's start going through some code of how different levels were done. So actually, starting at level 1, let me go through the objects of level 1 and then go through the code of it. So we got the editor madness window. It has our the title at the top. It has buttons, and it has the text here of what level we're on. It has the intro text, then the level 1 text, and then the and yes, I separated them just because could have made them the same, but whatever. And then we got a button here, and then we got this text that is spinning. We got the background image and my logo thing here. So in the hierarchy, we got all those things as well. So we got the intro background, we got my logo picture, and then we got a canvas that just has the text. And you'll notice that this has like an interesting like drop shadow thing going on. That is just done through basically having the text duplicated, and the drop shadow has to be drawn first for then the text over top of it to be drawn second. So we got on the canvas, we got the drop shadow text that's like the orangey one, and then we got the welcome text, or the one that's like the normal text that's the greeny color. And don't know why I picked these colors, they just looked cool, I guess. So that's that. So now let's go into the actual coding of the editor madness window. So for level 1 of all of these scripts that are being used, the only one that's really used primarily is just the editor window. So let's start there. So first of all, this is all the crazy code that's going on with doing the editor window. And that's, over 1,500 lines, but that's with a lot of spaces and comments. So not actually as long as it looks by technicalities, but it is quite long and a lot of complicated stuff going on. So, so to start here, most, basically all custom editor stuff, we're gonna have to use Unity editor things. So that's a thing you'll see as a commonality of all the editor things. So to start, we have some information that I need both this editor window script to access and another script to access. So I just made it a class. And yes, this could have been in a separate code file, but it's fine. So this shared reference class just stores 2 pieces of information: the current level that we're on, because another script needs to access that, and this thing is for a property jar that we'll get into later. I could explain this like from top down, but I'd rather explain things in the order of the levels. I think that's a easier way to go about it, I guess, rather than kind of going back and forth a whole bunch. So, and I've been doing that a little bit, but now we're going to really go into just level by level. So in the editor madness window, first I have to go through how the level switching even happens in the first place. But we get references to different things. Okay, so we get a reference to, this ends up being a reference to that text, effectively, long story short. Yeah, reference to the long pieces of text we need to read. And this is a reference to that level's parent. And as well, we are going to save information about some of the text that's used in the custom editor, just the styling of it. As you can see here by the names, a lot of the names here are maybe self-explanatory. Having a text style for bold and centered, and one that's just centered but not bold. So then we got different variables that have to do with each of the levels. So level 1, these are all the variables I needed for that. Here, all the variables I need for level 2, etc. Actually, these are the ones for level 2, etc. So, and there's a lot of spaces here. That's just to make it more organized, I suppose, just to look nice. So all we need for level 1 is a reference to that welcome text. And we only need a reference to one of them because the other one is the drop shadow thing is like a child. So we spin one, then it'll spin the other. Okay, so now skipping ahead through these variables, we can go down even more. Okay, so the first thing we need to do is set up this custom editor window to be able to be a custom editor window, and that's done through this initialize function, which is, first of all, this is setting it to be in like something at the top that we can click to open it up, and then this is a function that gets called when we open up the window, which is or when we basically click that button, which is making a new window and then showing it, simply enough. I believe this also does take care of not being able to have multiple of that window open at once, so that's cool. So next, on enable, this happens as well when hold on. No, yeah, this happens as well when we. Oh no, yeah, I am skipping ahead. Sorry, I was trying to remember why I did things the way that I did. There was reasonings. So yeah, on enable is just the setting up, getting all the references at once. Now, custom editor windows don't have a start function. They don't have an awake function necessarily. So that's why I use on enable. And also the initialize function has to be static, and that causes things. So by having on enable is a non-static function where I can get these references that yeah. Okay, so for each level, find all the references, all the necessary things. So just main every level, no matter where we are, we need like a reference to the levels parent and this scriptable object access thing. That's again all the long pieces of text. Level 1, we get the welcome text, and all of these are just like game object.find type things based on what we need to find. Now you'll notice a lot of these aren't just finding some of these objects directly because game object.find doesn't work with game objects that are not active in the hierarchy. So a way to get around that is by finding a parent object, this levels game object that we know will always be active, and then going .transform.find, and that can find things even if they're not active. So that's a way of getting around that. So in order to do that, because these different levels are activated or not activated at different points in time, we start with having levels parent. We know that's going to be active all the time, and then we find the different child objects of it, which means we do have to kind of have a lot of like find this. But this is happening on enable. It only happens once, so it's hopefully fine. And this was kind of, I think, the best way to go about this if I didn't want to have like public variable references or whatever. So you're just kind of going at like the highest game object that we know will always be active, and then slowly go down and down and down to find the thing that we want. And that effectively happens with a lot of these other things. So now, actually, we have an update loop here, which the only way this works is by having at the top a execute in edit mode. So actually, with having that, you can kind of have, I think you can have start, maybe. That would require going into play mode, though. I think you maybe have awake, but either way, I discovered that actually quite late in building this, that I could have an equivalent of the update function. That's different than on GUI. So update I basically wanted to happen like all the time, where on GUI, just skipping ahead there, skipping around a whole lot. This is a complicated project, so I kind of need to a bit. I don't have a script here. I'm just rambling away, and hopefully it's interesting. So this on GUI function is basically being called every time that the editor window needs to update itself, which is kind of every frame, but not. There's some times where it doesn't happen like every frame. There's some things here like the spinning of the text in the game window I wanted to happen every frame. So specifically in update, the if, so shared reference.page, that page is like the level number effectively. Actually, that's exactly what it is. Then we rotate that intro text and rotating the transform directly, easy peasy. I'm skipping ahead a little bit, is that this is where the moving the end text happens, but yeah. So next on GUI, this is basically being called every time the editor window needs to redraw itself, like what buttons are going to be on it and all that sort of stuff. Even text and like just the formatting of all that sort of stuff. Which in here also I have the kind of logic of the levels of like what the custom editor does when you interact with the buttons that are on it. So first thing we do is set up the level select UI and its functionality. And then actually I can just go through all this real quick. It's just that then we call a switch statement based on what our level number is, and then just call different functions depending on what level we are on. Simply put. And then we have all these functions down here, which these could have been like in their own classes potentially, but I like the organization. There's a bit of organization of having them like one by one, I suppose, but it functions as well, so it's good, and it is decently like organized and all that. So I mean, it's better to have this organized by having these in their own functions than just having them on the end of all those, which I initially had and then separated them later. Anywho, so this level select function, first we are setting up the GUI styles, and that's okay to do this here because level select will always be called no matter what the level that we're on is. So setting up the styles, which actually, no, I forget why, but I believe this was having problems when I was trying to have it in update early in on enable or something, but anywho. So then we want to draw the title text. We're going to use a lot of these throughout this project, this editor GUI layout.space. That's just putting like spaces in the editor window. So rather than having, if we want to have two buttons, rather than having them be right together, having some space between them. Yeah. So then we want to draw it. We draw the label field, which is just the Editor Madness title. So let me go back here. We draw this title, making it bold and centered. Then this custom function that we have down here that's just drawing a gray line. Actually, the only times we really do that is here and here. But drawing a gray line that looks very similar to the kind of gray lines that Unity's like inspector stuff and some of its windows have. So I was intending to kind of copy that. So I guess I'm just going to sort of skip ahead to this draw line function since I'm kind of following along with the code a little bit. That's like really, close to the bottom. So this is a function where it just draws a line based on a color. So first it puts a space, then it does this thing begin horizontal, and then sets the color of the text, which actually the only lines are gray. So I could have hard coded that, but I did have an option where you could put it in a color. So we could draw a red line if I wanted to. Just didn't end up using that. I thought I might, but then I didn't. That's okay. So so then we draw, this part's actually just drawing that line. And doing this begin horizontal and end horizontal thing are, we'll get into that later. It'll be easier explained with an example. Actually, no, I can't explain it. It's, to be able to have like multiple things rather than top down. If I go draw this text, then draw this text, draw this button, it's going vertically. If I go begin horizontal, then I can draw a thing here, draw a thing here, draw a thing here. That's the main way of how I've been using it here. There's a reason why I need to have it with the button. I think it's to get this line rectangle, or get this rectangle of to where the line needs to be drawn. Anyway, so that does that. Okay, back to the top. Actually, here, to be able to find more easily where I need to go. If I double click this, now I'll see when I scroll up, I should be able to see it highlighted up here when I get to it. Level 4, 3. Some of these are complicated. There it is. But no, that's here's where we just left off. So now that we've drawn this first line, this one, now we want to do this level select area. So in order to do that, first we, again, as I said, begin a horizontal, which is basically then making it so we can make GUI elements next to each other effectively in a way that scales with the window. So that's one thing that's nice about the way I ended up making this, is that you can adjust the size of it and it works for the most part. So that's pretty cool. So with that, then we go and draw the previous button, which is just going GUI layout.button and then the name of it. And then by putting that in an if statement, then this runs when the button gets clicked. So this is where we have button functionality. By you make the button, and if we clicked it, then do stuff. So now if we hit the previous button, then go to the previous level by just setting page number minus, and then making sure that we can't go below level 1. Then we want to draw just the end text here, and I adjust the label width before doing that just to be able to have the so it kind of automatically makes the buttons a lot wider and the text here doesn't take up as much space. Simply put, then over then there's a special thing where if we're on level 11, that's the end level, so we draw the end. Otherwise, we just draw level space whatever level we're on. And then set this back to what seemed to be close to what its initial value was. All right, next we have the next button, which does the same thing. It just adds whatever level we're on. And then if we go over level 11, that's the last level, that's the end, then set it back to 11. End horizontal. So that, and then draw another gray line. So that does this. So that's how all the level select stuff is done. That's just doing the UI stuff. Now, in this level select function doing its functionality, how we actually then get the next, or do the switching between levels, I should say, is happening right here, which is, as the comment says, based on the page number, activate the corresponding level object and deactivate all of the other ones. And that happens here. So nice. That this does what we want. I could have maybe tried to have this be more robust in terms of like, only do this when it sees that we have a different level than the one that we had last frame. But again, this works. I could have improved this and optimized this all day long, but it works well enough. I did a lot of optimizing before I even got to this point. Anywho, so now that is how all the just general custom editor window stuff is working, and that's how the level select that is controlling what level we're on is working. So now going specifically into level 1, which is just click a button to move to the next level and have the spinning text. And we actually already kind of covered that, is the spinning text is happening here. Now the actual level 1 logic is below here. So in its own function. So level 1, simple. All we do is call the intro text and write that. Just put a space and then the level 1 text and put 2 spaces and then make the button. That is here. And then kind of manually setting its height to be a lot taller. So that's a taller button. So it looks cooler, I guess. And then if we click this button, go to the next level as level 2, and then just more formatting stuff here. Now is a good time as any to go into more of the scriptable object thing of how we are doing this thing to have all that text in one place. So going back out to Unity, you can see here we have, this text here that matches the text here in this scriptable object. And if I go and type this, it's not instantaneous, but then it should, update over there. So nice thing to be able to easily edit this and see it all in one place. So in order to do that, first we needed a script to be able to make like what the scriptable object has all about it. And that's an editor script, I believe. No, it is not. I was just looking at it over here. This one, I believe. Yeah. So this. Shoot, am I going to remember how I did this? It's been a long time since I've looked at this. Sorry, no, this is the script. Long text storage. So this is the scriptable object in a nutshell. It derives from something called scriptable object, and it's neat. A lot of neat things you can do with it. But to simplify, all I'm doing here is just storing a bunch of text in one place. And doing that is just, a bunch of public strings in one place. And then it has this create asset thing to be able to, I can create one of these scriptable objects by just going right click, create long text storage. That will create that here, and then I can fill it in. And then what's also neat is that I could have multiple of these that had different things of text for some reason if I wanted to do that, and then like swap them out. That's something I could supposedly do, and maybe I will for future projects for other kind of use cases of how I might be using this stuff. So this is making the scriptable object. And now for the way that I currently have this programmed, I need a way to be able to access that text, this text, in the game view, in the scene. So in order to be able to access that scriptable object in the scene, I rather than just directly accessing the asset directly, is that I have this script here that all it does is just getting a reference to that scriptable asset. And then we can see that over here. So this has this script on it, which is just a reference to this. And this then has that interesting functionality that I can swap this out with other scriptable objects that are the same long text storage thing if I wanted to. That would be interesting, or that has the potential to do like language setting stuff, where if you had like, all your text that has to do with like in English and then the text in like Japanese and you swap them out. Well, you probably wouldn't do that just on one scriptable object, but anyways, I'm getting ahead of myself and off topic. So that is how the scriptable object thing is working. And then as we saw, the editor madness window then basically gets a reference to this thing in the inspector, and then through that gets a reference to the long text storage to be able to access that text. So that's how that's happening. So we can see that happening here. This was something that we got a reference to in the scene, that variable, the actual specific text that we're looking for. So that is how that scriptable object stuff is working, and it's quite neat and has a lot of potential for interesting things you can do with it. Here, I just use it as like an organization thing, but regardless. So that is level 1 done. It's the simplest level. All it is a button. Whoa. Okay. Now going forward, we should go through the rest of levels kind of faster because I don't have to do all the kind of introductory explanation stuff. So next we have level 2. This is doing math questions. So as we looked at already, this it's basically just testing that you're typing in the correct number. So this field, it's looking for you to type in a hard-coded 4, which is all right. And also you can't put in decimals. So that's another thing. And you can't put in other text. So it does force it to be an int. So that's a thing. All right, so now the programming behind that should be as simple as, well, to start with, just going down here. No, first I want to go through, to stick to the pattern, go through what's in the hierarchy, then go through the code. So the actual, what's in the hierarchy here is the math background, to start just for the fanciness of it. Then I have all of the check marks. This is the check marks as they activate, which is just, there's one here, there's one here, and then there's the third one. Then we got just the squares, that's just more of a background thing. And then we got a canvas that has the Q1, Q2, and Q3 text, and then we have these could have been also UI images, but I just happened to make them sprites, so it works. It does what it needs to. And then we got the question background, which is just this black thing around here. So that's a lot of this is just the formatting stuff of it. The only part that's actually changing or doing anything is these three check marks specifically. So those are the only things that we care about to access through code. So what we do is earlier, I'm not going to scroll up, but in the same way that we got the level text, we get all three of those checkmark objects. So then we draw the level explanation text in the same way. Then we draw the math questions one by one. So first we draw like the level, that first math question, the 2 + 2. Then we draw, actually there's like multiple things happening here in one line. We draw this int field that is this int field. And by just doing int field, that does the work for me in terms of only be able to put an integer, no decimals, no strings or anything like that. And then we have to basically give it a default value. And I have a variable that's just a public, it's a private float that is mathnum1 that's just storing the number that we've entered. So it gives it an initial value of that number. And then this will then return if we've changed it. So at the beginning of the game, it's -1. When we type in 4, this thing will return 4 and then put that in here. So then this is kind of this looping behavior where, because if I don't have this, if I just draw an int field, then it won't let us edit it. As soon as we try to edit it, it will just bring it back to what it was before. Because again, this is running every frame. So we put in what the player entered as the value of what the int field currently is. And then on that frame, if the user has typed in a different number, then we basically pass that to this new math1 number. So then it has this looping behavior of allowing us to change the number and save it, see what it actually is. So that's that. There's a lot of cases where we do things very similar here. Basically, anytime in the custom window where we need to have the user enter stuff and like save that, we're doing this framework here. So I won't need to explain it as in depth for all the later times we do that. Draw the second math question, exactly the same. Third math question, exactly the same. Then we go through the actual checks of did they enter the right numbers? And because of the way I have the check marks, I have to do each one individually. If I didn't have the check marks, in order to continue the level, I just need to see that all three are correct. I could just do that in one big if statement, but because I'm having the check marks as well as like this visual feedback for putting in the correct numbers, I have so testing the first one is 4, and I could have made these public variables, but a lot of the custom editor things I kind of hard coded what the correct answers are supposed to be. That's all right. This is not meant to be like a proper game thing. It just needed to function and was for the sake of learning custom editor things. So we, if they've entered 4, then activate the first check mark. Otherwise, have it be false. Same thing with 2. Same thing with 3. Next, now determine if we have done them all and can go to the next level. Basically, the same check of if all 3 are correct, then we draw the continue button. And that's how a lot of the the going to the next level is done. Is we save some information and then we're basically like, if the condition, the puzzle has been solved, the condition has been satisfied, draw the continue button with it going to the next level. And I know that this could have been probably like shared reference.page ++, and that would have gone to the next level for all of these, but just to make it less likely to bug in case some weird thing of like if you can somehow click the continue button twice in one frame or something like that. I just hard coding it to 3, make it like less likely to be able to go wrong effectively. So that's a thing I did intentionally. So next we are on to level 3. So going to level 3 and just skipping ahead. We got this moving the slider back and forth to correct position. Correct spot is 5. So again, that ends up being a hard coded thing. So all that happens here, if I expand this one now, all there is the arrow or the slider cube, which is this cube. It does have a box collider. I guess it doesn't really need it, but it was just me making a default cube. And then we got this arrow, which is just made out of tiny rectangles. That's all just, visual, basically. So the only thing we actually need to access for the functionality of this is the slider cube itself. So that's all we do access. So now back over here. First, same story of we draw the explanation text, and then now we draw the slider and save the result in the exact same way that we got of how we draw and save that number field from before. So we draw the thing here, and we get the number. I put it between -8 and 8 because that was just kind of where the cube would be going off screen. I round it to an int on purpose just because it makes it easier to line it up to the correct position if it just rounds to an integer. So yeah, and then we save that here so that again this looping functionality of how that slider works. Next, now that we have the slider number of where we move the slider, we move the cube based on that, and it just happens to work. I've designed it on purpose this way. Is that like the slider's numbers it goes between kind of match where the cube would need to be in the scene view for that to match up. So then we just basically make the slider cube's position the slider number along the x-axis. Now for the correct condition, we just test if the slider number was 5, do all this stuff. Draw the continue button. You'll notice this is all like exactly the same, except this is a 4 instead of a 3. So yeah, that's that. Again, if I really wanted to, I could have had maybe a separate function that's like draw continue button, put as input the page number it goes to. I could have done that. I just thought of that now, but I didn't, and I'm not going to change it now. That's fine. So next, we're on to level 4. We're going through these faster. So next, actually, well, I say that, but now this level is a lot more complicated. The tic-tac-toe board. So first, going through the hierarchy, let's go do that. So we got some stuff here. So first, we got the board. This is just the visuals of it being a tic-tac-toe board. And then for each of the positions, I'm going to actually go in the game view to betterly see this. We got empty game objects basically for each spot, and I did this to do a neat thing where I can basically do this. So in the top left, this is a circle. I can change here whether it's a circle or it's an X or it's blank, which is really cool. Unfortunately, the actual like game part of it doesn't really make that much of a use of this. It does a little bit with the placing the X in the correct position, but in terms of like changing O's to X's and X's to O's, it doesn't do that much. But it made it easy to actually set it up when I was building what does the initial state of the tic-tac-toe board look like. So this is being done due to some other custom editor scripts. So let's go check out that. So first of all, as I said, the actually if I go looking underneath each of these empty game objects, each one of them has the X prefab, which is it's just the model of it effectively, which is 2 rectangles, and then the O model is the or the O prefab is just the O model. So that's all the prefabs are, so I don't need to check them out. It's just the model, effectively. So each square, each spot, has as a child object a potential X or an O. And the long story short is that this script, when you change these back and forth to different values, it either, if it's O, it turns on the O and turns off the X. If it's the X, it turns on the X and turns off the O. And if it's blank, then it turns off both of them. So that's the quick way of how that is happening. So then going into some code things that how I make that happen. So this X and O's spot decider, let's go check out that first. That would be over here. So this is having that enum that you were just seeing of having blank X or O, and then getting that as a public thing to be able to see that in the inspector and change it. So then we have 3 functions here that describe the functionality here of the 3 states that we can be in. When these functions are called, it does exactly what you just saw in the inspector. If it's blank, it deactivates both. If it's X or O, then it activates that one and deactivates the others. So that's how that works. Now, you'll notice that, or like, oh, how do we actually, call these functions? What's actually doing that? Well, that, my friends, is through the power of custom editor scripts, which this project is also using, in addition to the custom editor window. Well, this is actually the only instance, I believe, of it using a just straight up custom editor window. So this is custom editor window stuff, which is also complicated, but he was able to figure it out and all that. The window was harder for sure. Just it causes a lot more problems, but we were able to get through it. Anywho, so this custom window, you say what it's basically a custom editor for. So basically, a custom editor script determines like how the other script that it's a custom editor for should be drawn. And then you can have some interesting functionality from that. In my case, I had that interesting functionality, actually change things in the game view when you change that enum value. So that's neat things there, which again, this has to do with having this functionality exist entirely in the editor without going into play mode. So that's the other side of that. So this custom editor script is first, this on inspector GUI, this is on inspector GUI is the function of how it draws the stuff that's in its editor thing. And it starts by just drawing the normal GUI elements. So I don't need to tell it to draw this enum. I wanted this enum to be public. So I'm having it public, and it's like the only thing here. This is effectively going to draw that enum on the side there in the inspector. Then I want to actually get a reference to the, basically to this code from its own editor script. And that happens with this fancy target variable that exists. That actually, well, specifically this has to do with the one that's being inspected, which will be the one that we're selected on, that we're looking at in the inspector right now. So that's that. And then depending on what we've set that enum to, then we're calling these different functions. Yeah, that is how we're doing there. So yeah, looking at what the enum value is and then calling these functions here, that's then actually changing the visuals of like whether it's an X, an O, or blank. So that's pretty neat there in how that works. And then the custom editor window uses that in, I believe, sometimes manually calling these functions to, in our case, just put the X somewhere or make it blank when we're trying to complete the tic-tac-toe board. So the custom editor window never actually calls the O1, but that's okay. It's just the way it happens to be here. I could have programmed like full on tic-tac-toe like with an AI, but I didn't need to get that complicated with it. Just this was complicated enough. And yeah, it does the job of what it needs to do. So now onto the code of level 4. So again, as every level starts, it draws the explanation text for that level. Then we draw the first row of the tic-tac-toe board in the GUI. So we in the GUI, let me go and look at it. So you see here, it's a row of 9 things. So again, following with the that begin horizontal, end horizontal thing I was explaining before, of we're basically go begin horizontal, draw this button, this one, end horizontal, begin horizontal, So that's pattern kind of how we're doing that. Which does mean that we have to kind of go and draw each button individually because they all kind of are different. There's no easy like for loop that could help us do that because they're all quite different in how they function. So we draw an O button that you click in it does nothing. It's just to have the style of it match the others. I could have maybe had these be grayed out, but it's okay. It works. So then there's 3 spots that you can click, as you can see here. These are kind of hard-coded of the top middle, the bottom middle, and the bottom left of the 3 spots you can pick to try and complete the tic-tac-toe board, but only the bottom left, which is spot 2, is the correct one. So with that, we draw the button that is spot 1, and this is a variable up top that is, what type are you? You are a string. So you're a string that's either a bunch of spaces or an X, based on whether it should be a blank button or have X written in it, based on what the player's currently clicked on. So with that, if we have clicked spot 1, then some things need to happen. So if we weren't clicked on this, when we click spot 1, wham, we need to now draw an X here, change the X to this to being an X in the inspector, and then remove X's in both the buttons and in the actual game. If there was X's in either of these positions, then get rid of both of them. So that's what we're doing here. So the stages of doing that is just first just swapping what all the text of the buttons should say. And I put there's 3 spaces here just because it makes the buttons have the same width as if there was an X for some reason. If I just made it an empty string, then the empty buttons become thinner. So that's that. And I guess I could have put them with a desired length, but it's okay. It works. It also makes it so that even scaling the buttons, scaling the window, they stay being the same sizes. Anywho, so doing that, we set up what the buttons should say, and then we change that enum. But changing the enum here wouldn't immediately call where is it? The editor script. Where did I put it? It's over here. That's not going to immediately make this run because we're not it's not going to redraw the inspector. This happens when it's like redrawing what's in the inspector. So it's not going to call this right away. So that's when we also need to manually now say, set that one to be an X. So that's that. And I forget how, but this does deal with somewhere I deal with it down there. It's going to set spot 1 to being an X, and then down later in the code, it's going to set the other 2 to being blank. So then we draw the other button, this one. Then we draw some spaces just for the formatting of it. Now we do the second row. There's no buttons you can click on the second row, so it's as simple as just OXO. That's these 3. Now the last row, there's the 2 buttons we can click. So a lot of this is very similar, so I can go through it real quickly. We draw the spot 2 button. This is the one that's considered the correct choice. And then we replace X, replace these with blank, set spot 2 to be X, and then do the same with spot 3. And then draw the last other one that you can't click. So now, having done that, we now look at the way of sort of resetting the other spots, I remember this was being kind of weird when I was trying to have it be part of up here. It was just kind of better to have it having every frame like on its own down here, which is that now it looks through all 3 spots, and if those spots are blank, what the button says is blank, then make sure that there is no X no X or O in that spot in the inspector. So not in the inspector, the enum value, and in the game view. So do that for all 3. Now, the correct spot is considered spot 2. So then we just look at if that thing we saved is an X. That means we've clicked the correct button. Draw the continue button. Easy peasy. So that worked. No, it was not easy, I should say. This was quite hard to set up. But having now explained it, the logic, hopefully that makes sense. All right, so now level 5. This one was a nightmare to code, but we got it all figured out. Let me just move this over so that this is completely cut off. So again, it's a choose a number between 1 and 10, and the correct number is 3. The wrong ones have text underneath, and it actually does show the text over here. So in the hierarchy, we have level 5 here. We have the numbers background image, and then under the canvas, we have the numbers text panel, which is just the black box. It's wide enough to be able to fit the 10 and look nice. And then we have actual different text objects for each of the numbers, which is then it's just turning on and off, which makes it very similar to how we did the level switching functionality. I could have tried to have just one text object and change the text of it, but this was easier and more similar to what I had done before. And then it also now, so all the other text is red, and the 3 text specifically, because it's the right one, is green. Simple enough. Yeah, so that is that. So now the actual coding of this becomes really complicated, because if I was just doing this in the same way that I set up the other levels, it would have been a lot easier, but I purposely decided to try and set this up with something called property drawers, which is having custom properties and then having custom, like telling Unity how to draw that stuff in the inspector. And it's complicated. So hopefully now I can walk you through how I went about actually doing that. So starting over here, let's just start here. Seems like the best place to start in the level 5 text. As always, we start by doing the level explanation text. That's the easy part. Now, as you can see, we have this enum here that's between, it's 0 and 10 if you're going by like array numbers of which one we currently have selected. So what we do is go editor layout.property field. This is this custom property field that we've made. New serialized object, this.find property number guess. This is very confusing and complicated to get set up initially, but the long story short is just that this finds it gets that number guess. This is drawing that enum and the text beside it, actually. Actually, it's drawing more than that. It ends up drawing the text here, this enum, doing its functionality, and having the text under here when we're wrong, and having the, oh no, wait, why did you just break? Oh no, what? That's new. Hopefully it's fine. Did I think I've, because I was just messing with stuff in the hierarchy thing. Oh, whatever. It was working. It's been working all this time and only broke when I started going through my code. So I'm assuming that I've just messed something up now in the last few minutes of doing this. Anyways, I'll worry about that later. Anywho, so this essentially just is drawing all of that stuff. And I just have also a comment here that the continue button is also handled there. So we have some other scripts that's doing that. So first of all, we have number guess. This is the place where we're saving what number that we're accessing. So, or what number we're guessing. So we just have an enum of our 0, our initial thing, and then 1 to 10. Then this is getting a reference to this enum, getting like a variable that is that enum to be able to change it, and then setting the default thing of it is going to be the top one, just because that's how that's set up. Then we have property drawer. So this is setting up basically like this property, this class. Actually, more specifically, yeah, it's like this class, and then we're now telling Unity how to draw that class, but we're also then mixing, or how to draw that class in the editor, but then also mixing in functionality inside of that. So to do that, first of all, we're deriving from another special thing that's not mono behavior, and that is a property drawer. All the different parts of here, it's a bit complicated, but going through it in a way that hopefully makes sense is, so first our variables we have here is storing what our current saved guess is. This was really hard to save and access and all that, but yeah, so we are saving, that is the current number that we've guessed, essentially. Then the same GUI style here, I've had to make that stuff here. Then rectangles, the rectangles of kind of defining these spaces where it's drawing the different parts of the UI. So guess a number rect, that's this label text, the rectangle that it's going to be drawing, where it's going to be drawing this text. And then there's the rectangle of where it's drawing the enum, and then there is also a rect of where it's drawing the wrong number text. So that's these. And then we have a reference to the serialized property that is the number enum. Basically, this is our way of getting a reference to this. And then a reference to the numbers text parent to actually change the text in the game view. Yes. Okay, so then we have this function on GUI. This is being called every time we need to draw this class. And in order to do that, we first are setting up the GUI styles. Then we're setting up the different rectangles of where they're going to end up being drawn, and that has to do with screen width stuff. Doing screen width. Screen in this instance is the editor window. So screen.width is the width of the editor window. Doing some fancy math that is having the position where it starts and the width and height of it be in this exact style. It was a lot of playing around to get it looking how I wanted it to. It just look, good enough. Next, we draw the guess a number text. That's the easy part, just drawing a label. Now, this is where things get more complicated of trying to draw the enum and being able to change its value and save all that and what have you. So the first it finds, find property relative number. This number is the over in here. It's this variable effectively. It's from the number guess thing. It is getting this number variable, which again is this enum. So it's basically just getting the enum. Then we are at the beginning of the frame. We are setting what its starting value is going to be to what the save value was last frame. So that's how we're setting that up. Then it's very similar to what we did with the I'm gonna use that as an example. The earlier with the getting the numbers from math questions and having to have that kind of looping functionality. That had a lot of stuff that it kind of did things for us where it all happened in one line. With the property drawer stuff, I basically had to do a lot of that manually, so that's why this gets a lot more complicated. So we basically are setting up what that default value was, which is the value it was last frame of if the user changed it. And then we draw the enum and new GUI content blank, because you can draw enums with a label at the beginning, and I basically made that blank because then I drew the label as a separate thing. And then we after having drawn this, we're now then able to see, did we just change it? Did it change this frame? And then we are saving that for the next frame to then have that be the starting value. So that's how that's working. Next, then we are getting a reference to all the text objects, and then we are going through and then making the right one active while all the rest are false. So again, very similar to how we did the level thing. So if we've guessed 5, make the 5 text active, make the rest false. That's how that's working. So now the correct number is 3, just the way that this is. Again, if I wanted to go really complicated, I could have made it's a random number every time. But again, didn't need to get that complicated with it. It's already complicated enough. So if we guessed 3, if the saved guess is 3, draw the continue button. Easy. With then also a special thing, I guess. Well, not a special thing, is that if we didn't guess 3, so any other number, then draw the wrong number text. And that's kind of happening in place of the continue field. With the exception of on the initial state before we've guessed anything, when the value of the enum is the choose a number, we don't draw any text there. So that's how that's working. And then another thing down here is how it resets itself. In the editor window, actually this is the best time to go look at this. If you remember, way up at the top here, this shared reference thing, this is also having a reset variable here. This is for, I have a function that is resetting everything, so resetting like just all the puzzles. That gets called when we first make the window, and it's getting called, if you remember on the ending page, that reset button, that is doing that. In order to reset the property drawer stuff, and the text and all of that stuff, we're basically setting this reset boolean to true, and then the property jar picks up on that and then resets itself. So more specifically, just resets the saved guess to 0. So that was a thing. Because the editor window in this property jar can't connect directly, so or at least I couldn't find a good way for them to. That wasn't even more complicated. So rather than them try to calculate or communicate directly, they basically both access this higher this other script. Well, not other script, this other class that is this shared reference thing. So yeah, that's how that's done. Basically, actually, that is exactly how it's done. All right, that is level 5 done. The hardest level easily, just because I tried to do all that property jar stuff. If I was just doing the way I did all the other levels, then it would have been a lot easier, I think. So level 6 is the one with the toggleable lights. So back to what I think was the easier stuff. So level 6, and we're getting through this. This is definitely taking a while to get through all this, but that's okay. It's a big project, a lot of moving parts here. A lot of moving parts where I had to move everything manually rather than all the stuff that usually Unity stuff can do for us when you're in the game view. Anyway, so level 6, we have the little like background thing here. I should also mention at this point, there's a skybox that's like slightly tinted. It's just a random color for the pizzazz of it. So then we got these toggle lights, which are all just lights. They're all just, if I move up these lights, they're all lights with draw halos. And then some of them are green and some of them are red, just the way that is. And actually, if I move them here. So they're draw halos like this. I discovered this by accident. Initially, there were just going to be lights like this. That was the initial idea when I was building it. And then when I was setting up this environment thing, I accidentally had the cube like intersecting with them. And I don't know why this works, but it happens to make this perfect cube shape. Something weird happening, but it looks cool, so we're using it. That's what we're doing. And it only works when you're viewing it exactly from this top-down perspective. So yeah, we made use of that. So then we have different empty game objects here that it's a lot of the same thing. A lot of the interacting with what's in the game view is just activating and deactivating certain objects based on values in the custom editor. That is how a lot of this functionality is happening. And it was kind of designed that way to be similar on purpose. So we have basically these different empty game objects that's like 1, 2, 3, 4, 5, 6, 7, 8 for the different lights. And they get activated or deactivated based on the toggle values. All right, that's the hierarchy. Back to the code. So I have to go find the, all the way down to, what was that level? This is level 6. This is level 6. Down all the way to, I passed it. Over here, level 6. Okay, so again, as all the levels start, we draw the label field, and then we draw all the toggles. So this is very similar to how we did anything else that we've drawn that we've been able to interact with the weird exception of the property jar thing, where we draw the thing. In this case, it's a toggle, and we give it what its default value is. This is just a Boolean, it's true or false, and then we plug that back into here. Whoop-de-doo. This possibly also maybe could have been an array if I tried harder with it, but it worked. So yeah, then for each toggle light, then we are, with each toggle Boolean of if it's true or false, then we are going through and activating or deactivating that corresponding number in the game view. So we go through all of that. Then we basically test the password thing. This could have been just that they're all true, and if they were all true, if I did have to test that they were all true, then I may have just had this been an array, but it was kind of easier, and it made, I don't know, it looks nicer here to just be able to be first setting the password of what is the correct option is like this one false, this one true, true, false, true, false, true, true. That's the correct combination. And then the colors of the lights is just like how I colored it in the inspector to or in the game view to match this combo. Then if we have the right combination, draw the continue button. Simple as that. Cool. Almost there to the end, kind of. So then level 7, this one is actually on the easier side. It's just draw text, do hello world. And this is happening, as I did kind of allude to this before, is that all that's happening here for the having the text be here is just I found a nice image that had this hello world text in it. I photoshopped out the hello world part of it and then have both of them. And basically if you have the wrong text in here, it shows the blank version. And if you have the right text in here, it shows the correct version. So like the one where it's all filled in. So that's that. Then the actual code behind it is just here. So we draw the introduction part, the level explanation. Then we draw the text field that we draw the text field, and it's just a text field. This logic is the exact same as how in the math one, how we tested that they entered 4, or they entered -3, or they entered 0. This is just getting that, letting them put in text, and it's saving the text that they entered. So the copied text, them trying to copy hello world. Then we, down here, just test that they entered hello world. Yeah, and I just did a dot lower thing just in case to make it, I don't know, slightly easier to have put in the correct wording, I guess. So then when we've done that, then go and, this is a dot find. Oh, that was maybe something I meant to change out at some point, but like to have it just be something, it gets the reference once, but that's okay. Oops, oh well. This doesn't get called very often. Actually, I guess this is being called every frame. Oops, but oh well. So actually it's only called every frame that we're on level 7 specifically, so it's slightly better there, I guess, because every level thing is quite independent. So yeah. But anyway, so if we've entered hello world, then we set that hello world image to true. We have that visual feedback, and then we draw the continue text, or the continue button. Yeah, cool. Level 8 then is, I forget what level 8 is. Oh, the button one. Oh, this one was cool. Had to do a lot of stuff of coding things manually, unfortunately, but was how it was. So this level over in the hierarchy, again, just recap, these are all buttons that when you click them, it cycles between colors, and then there's a bunch of cubes that match those colors. So in the hierarchy, there is, I just lower all of these, and now we're on level 8. So we just got the button color cubes as the parent object, and then we got the 25 buttons. Each of these buttons has its own mesh renderer material here, and just because of weird wonky things of how custom editor stuff is, of doing things in the editor, I had to give each one of these their own material, rather than, I tried initially just having them all have the same material and changing the instant version of it, but it doesn't like you doing that when you're in the inspector. So apparently I guess it's just better to have done giving them all their own materials that changed. I guess technically, now that I think about it, if I wanted to go even, I guess one thing I could have done in making it slightly better is that just have a material for color cube, red, green, blue, and then when I change this, then I swap out the material. But then I have to get access to the, I'd have to maybe have that in a resources folder or something, the actual materials to do that, or something like that. Anyways, because getting public variables that I drag and drop, you can't really do that in a custom editor window, probably not easily anyway. So I'd have to do like a dot find kind of thing to get that, which then I'm getting references to materials, and then that becomes, so I have to figure out how I'd be doing that. But anyways, So level 8 though, yeah, then the coding behind it is that it grabs the explanation text, or as always, then it's a variable for the size of the buttons. I've basically been able to, in one place, set the width and height of all the buttons. As you saw here, if these buttons are all squares, I could change all the buttons in one place, the sizes of them. Anyways, so now I have to go through and draw each of the 25 buttons, and I couldn't find an easy way of having this be an array of 25 things that has this all the same, just with weird stuff of because it was in a custom editor. If it was just normal Unity, like in play mode stuff, I think I could have, but because of weird custom editor things, I wasn't able to, get it to be, so I didn't have an array of, or 25 individual objects that I now have to have the clicking of those buttons all individually. Anywho, so now what happens here is that this is drawing one of those individual buttons based on the width and the height, with having no label in the button. It's just blank, so it looks more just like, it's just the color. First of all, also I changed this is changing the background color of the button to whatever the current saved color is. Then then it gets the mesh renderer of that cube associated with that button. And then and that's actually, this maybe also could have been a thing I got a reference to, but oops, again, like more things that could have been optimized, but again, that's okay. It works. It took a lot to even get to this stage. Anywho, so if they click the button, so this is an if statement. If they click the button, we now want to cycle to the next color. So get that mesh renderer, and then if the button was red, make it green, and then change the materials color there. Just going this .material.color, it doesn't like you doing that in custom editor stuff when you aren't in play mode, because then that's like the instant version of that material, and I think it leads to like memory problems. So yeah. Then if it's green, it changes to blue, and then if it was blue, it changes to red. So that's that cycling. Do that 25 times. Because also, I guess I didn't show this, at the very top of the code, I set what the initial state of the button was. So I can set up both in this one, setting up the password system of what the kind of default state of everything is, and here setting up the default state of all these buttons, which I made a nice pattern out of, I guess. That was another thing that was tricky because I didn't have the same kind of awake start functionality that you'd have with, or even like public variable references that you'd have if you weren't working in a custom editor window. Deciding to do this in a custom editor window instead of like custom editor script stuff made a lot of this a lot harder, but I learned a lot, so it was worth it, I suppose. So next, once we're done drawing the things for all 25 buttons and doing the same thing of swapping them out, now we have this really long line where basically, first of all, we just set the background color back to white for any future buttons that we might be drawing, like the continue button, or even if we go to another level, basically just resetting that. So then we are testing if all the buttons are colored green, that is the correct thing that we want to happen. I could have then made this the same kind of passwordy thing if I wanted to, but I didn't do that. So then we are going through and testing that each button is green. If this was a for loop, this could have been a lot nicer looking, but that's okay. If they're all green, draw the continue button. Ta-da! That works. Next, that's level 8 done. Woo. 2 more to go. We're getting it. This definitely took longer than I thought it would to go through all this, but that's okay. Hopefully I'm being thorough in my explanations so you understand why I'm doing the things that I did and how I went about making all this. So now, level 9. It's the only level that does other things in the inspector in this level, where if it wasn't up before, it makes it so now the wireframe Suzanne is always the selected thing that's in the inspector. And then this is basically mocking up the transform to be able to change position, rotation, and scale. Make sure it's equal to this one's position, rotation, and scale. So that's that. The actual what's going on in the hierarchy, by again starting with that, as is what I've been doing this whole time. So we have the Suzanne, and actually, if I go back to the editor window now, you're gonna see it snap back. We got the Suzanne monkey here. That all that's important on here is its transform, and we got the wireframe one looking at its transform. So I get references to both of those, and then in the level 9 thing, we draw the explanation text, and then go through all the position stuff. Where again, this is the exact same as like the first thing that we did, the second level where we did the math questions, where we were putting in numbers and then saving them. Exact same thing. I'm just then labeling this as position and putting X, Y, Z for the formatting of it. Then doing the same for the rotation and the same for the scale. So at this point now we have 9 values that are saved for the position, rotation, and scale of the X, Y, Z in the exact same way. I don't need to go over this again. These are float fields, although instead of in fields, I guess that's one difference. Yeah. So then I, as just again, this is more of a choice thing, is just to round all the positions to the nearest 0.5, which this does some fancy math of how that does. It multiplies them by 2 and then rounds that number and then divides it by 2. That has the effect of rounding it to the nearest 0.5. These ones rounding it to the nearest 10. Similar math that does that. And then this rounds it to the nearest 0.5. Just how I decided to round these numbers to make it a bit easier to line them up if you aren't going by the inspector, which you should, I guess, but you don't have to, I suppose. You could just guess and check. I suppose that works. So then we get this is the setting the active game object in the inspector to being the outline monkey. And I'm doing this in the equivalent of like update because I want it to, if you click on something else, it will set it back. Well, it does it every time that the editor window updates. So that isn't actually every frame like an update thing, but often enough, I suppose. So then now that we have those saved positions and rotations and scales, we want to set the monkey that we are moving to have those, to match those values. So that's just new position, Quaternion.Euler, and a new vector 3. So simple enough. That will then move the monkey. And then now that we've moved it, now we just want to test, does the moving monkey's position equal the moving monkey outlines position, rotation, and scale. So that's just doing all this stuff. It's not enough to say does the transforms equal, because they could be different transforms that happen to be set to the same values, I suppose. So yeah, that's that. Then if that is true, then we draw the continue button. That's that. Now we come to level 10. I put this big explanation here of how the maze game works. That's level 10. It's the maze, which is the one that I think is the coolest. But also, I'm biased. I made it. Why can't I click this? Oh no. Why is... Don't break on me now. I'm in the middle of... Okay, I don't know why that happened, but sure. Did I save and recompile code? Oh, maybe that's why. Was it in the middle of recompiling code? Possibly. Okay. Skipping to level 10, the maze level, where again, last challenge, hardest of them all, use the directional buttons to move the cube to the end of the maze. So it's got like custom collision detection, and it moves this cube all around. It doesn't go through the walls, and then there's an end over there. So the hierarchy is actually where a lot of the how this is being set up here is working. So we have the player, that's the little player cube, simple as that. We have the goal over here, that's a thing that's positioned. And one thing that's also cool is I could actually move this goal around to a degree, and it would still know that it just, because it's the same kind of testing that the positions are equal for the player and the goal, so I can move them around, and the maze will still work. It's not, that part isn't hard coded, but the walls are kind of hard coded. So we got the background, just the white background because it looks nice, and then we got the walls, which this took some tedious work, but it works. So yeah, basically how this works is if you imagine the maze like a grid. Let me just kind of do this. So if you imagine the maze like a grid, I basically set up that each wall acts like it knows its position as if it was a grid system. So this being 1, 1, I think this being 2, 1, 3, 1, 4, 1 down to 13, and then 1, 1, 1, 2, all the way down to 25, I believe is the largest one there. Or was it 26? It was 25, yeah. So then each one of these cubes, they are named based on the position that they're in. So I had to go through and set up all of these manually. And now if I wanted to, let's say, move this cube down here, then I'd just have to rename it. I could have maybe tried to do some really complicated, crazy math to have, like, in the start function, it knows what number it's supposed to be. But I didn't do that, and I didn't need to. So, yeah. And again, this is a lot of why this collision detection needs to happen this way is because of the custom editor stuff. Yeah, so that's that. So once now all of these, I have this whole grid system set up. The cube in its code, while in the editor script of accessing the cube, has saved the cube's position. And actually, because I'll explain the logic of it before I actually go into the code. So if the player is here, let me go. Let's see. Wait, so this would be 1, 2. It's hard to. So from here, this is 1, 1, 2, 3. 1, 2, 3, 4. Let's say 4, and then like 1, 2, 3, 4. So 4, 4 actually. So right now the cube is at 4 as a row and 4 as a column. If it decides that it wants to move right, so to try to move here, so that would be 4, 5. It basically searches through all these walls and looks for, is there a game object with the name 4, 5? And it's not game object.find, it's transform.find, so that it just goes through just the walls, but which makes it slightly better. But basically, if it decides it wants to move right, so it wants to move to 4, 5. So is there a game object with the name 4, 5? If there is, that means there's a wall there. So don't move there. So don't move at all. If there's not an object with that name, that means there is no wall there, which means I can move there. And you can see that this functionality, this works, I believe. If I delete that, now I should be able to, snap back there, but now I should be able to move through there. So, and then if I bring this back, now I can't move. So that's cool. It has a bit of, not super hard-coded. It is hard-coded in that if I were to move this here, it's going to treat it like there's still a wall here, but now there's not a wall down here. Again, I could try to fix that by having it do more crazy custom stuff of like knowing, like automatically naming itself depending on where it is. But again, I didn't need to go that in depth with how robust this system is. Just having it be a maze is cool enough. So that's the logic of how that's happening. So now I'm in the code, checking that out. Again, we start with the explanation text, and here's basically the explanation of what I just said. We're going to read it again because you have to maybe be more, because I don't know how confusing this is to get the concept of what I'm trying to do here. So this is just, I guess, another explanation of it that's more in-depth than what I just said. So for the maze game, each wall is based on its position in a grid-like manner, 1, 1 being the top left, 13, 25 being the bottom right. Collision detection is done by when the player goes to move, searching for a wall object matching the position it wants to move to. If a wall with that name exists, the player can't move. If no wall with that name exists, then no wall exists there, thus the player can move to that position. For example, if the player cube is at position 5, 3, and it wants to move down, that would put it in position 6, 3, because the first number is the going down, the second number is the going right. Thus, it would look for a wall object with the name 6 space 3. If it finds it, meaning there's a wall there, it doesn't move. If it doesn't find it, so there is no wall there, it moves. It's like kind of inverted. If it finds it, don't move. If it doesn't find it, move. So that's how that works effectively. So in doing that, first we have to just draw the buttons. All that's happening in the UI here is just the buttons. I was considering maybe having something similar to this level where it draws all this, but like reflecting the maze. But I decided to not do that because, again, like this, I had to set up each one manually like 25 times. Here I might have had to do the same. I don't know. I just simplified it. This was complicated enough. I just had just the buttons here that control the game view. So that works. And it's still cool enough, even just being that. So we draw the up button, and when we click up, this is now the logic I've just said in action. So it looks for, this is the wall's parent, that's the parent of all the walls. It looks for an object with the name, basically where we're trying to move. And if it equals null, meaning it doesn't exist, then subtract our Y position. With again, so 1, 1 is the top left, 13, 25 is the bottom right. So moving up will mean like subtracting that grid thing to move up. So that is how that is. Then it draws just the more formatting stuff with spaces and begin horizontal, end horizontals, all that stuff. Then we draw the left button. Easy, like the same sort of thing. Then we draw the right button, exact opposite. And then we draw the down button, just have that like structure of how the buttons are. that's how that works. Then the more complicated part, which I could have maybe used some of the logic in here to have the walls auto name themselves, but I didn't do that. This is the part that actually moves the player based on that saved X and Y position, which I basically had to map the grid positions to what the transform positions would be. And that required some complicated math that had a little bit of trial and error, but I was able to figure it out. The one thing is that I know that just in order to have the kind of sizing of how these cubes like match with the game view, basically, or to match with the the dimensions of the camera is what I'm trying to say. That took some playing around, but then once I got that, basically I see that, or I know that each cube, there's a, rather than being like by 1 or by 0.5, it's by 0.75, that going like here to here is moving by increments of 0.75. That's just the way that worked to look nice. So then basically I know that multiplying the position by 0.75 will move it along those increments, but then the starting position, like button 1, actually technically these start at 1, 1. The equivalent of what button 0, 0 would be is negative 9.75 and 5.25. So then that is where these numbers come from, that kind of offset. So that is mapping that. And also the Y direction is like flipped of how the real world, the transforms like Y position goes. And I say Y position, technically it's moving to the Z position, but I was treating those variable names as if like this was 2D, and usually this would be like X and Y, so that's why I named it that way, but technically this is the Z axis, but that is my rationale for naming it that way anyways. Okay, so then we have if the player has reached the goal. So so that's doing all the collision detection stuff, that's doing the moving the player. Now the win condition is just, we had that goal object, which I can move that around as much as I want. If the player is not in the same position as the goal, that's our win condition. So then we make the continue button exist. Cool. So that is the last proper level. There is some stuff going on in the ending, so now we will go over to that. Yeah. So the end, the one special thing, I guess, is I just made the end text be bold instead of not bold, I suppose. Like the other ones. So a little special formatting there. Then just the ending text. I didn't really know what to. It's hard to come up with what to write for all of these, but it works. And then there's a reset button, but then also on here we have this text that's waving back and forth. So that's neat. All right, so now in the ending, the actual code. No, hold on. Let me go to do the hierarchy first, just to stick with the formatting of how I've been going through this, I suppose. All right, level 11, we have the background image, just my little banner thing, and then we have the canvas, which has this ending panel, and then it has the same thing of having a drop shadow and not like not the drop shadow, just the normal text, and it has the yellow panel as well. Now, because these are all child objects of each other or whatever, I only need to rotate the panel, and then the other parts go along with it. So that's one thing there. In doing that, so we draw the ending text, and then we I don't do the same formatting that I did with the other ones, did I? Huh. I went this and space, but I guess I didn't need to here. Or no, I do. It's just spaced out differently. Anyway, so draw the ending text and then draw the reset button. That's all that's actually happening in the function here. We did have a lot earlier, if you remember, what we get a reference to, actually in here, this is, as I skimmed over this before, of where we're getting references to all the different objects that we need in the scene to be able to change stuff about them. But we get a reference to the ending panel, and then in update, in the same place where we were spinning the intro text, we then set the rotation of that ending panel based on a sine wave that goes up based on time.time. So that makes it that's basically making this oscillation like this, and then I'm using that in the rotation to wave back and forth. And then this was just changing like amplitudes and frequencies, or just basically tweaking numbers in order to make it look better in the just how the speed of it was, essentially. So that's how that's working. All right. So yeah, and then I think that basically brings us to the end. I think we're basically done here. So that took a while, but yeah, hopefully it was interesting for you to go through why I made all this stuff. Nope, I'm not done just yet. I missed one thing. Reset function. Let's do that first. we'll do that last, I guess, is what we're doing now. But so the reset function is just when you click this, it resets all the variables in the game, essentially. And in doing that, for the level variables, sets them back to their default values. It does that. It only really needs to set the values that it's saving, like the numbers, and then on the next loop of running the on GUI stuff, that stuff kind of takes over for fixing up what the game view is supposed to look like. So, and then a lot of these, like with this setting, some of these default values were not just all the same, like drawing a kind of a pattern thing like I wanted. Again, stuff like this that made it also harder to put that in an array where they don't all have default values, because I purposely basically set these up manually, so I was going to have to set all these manually anyways, so there is that. And then getting the mesh renderers of all of these, so that's that. Then continuing to reset all these variables. So that is that. I believe at this point I've now gone through every script. So I guess a last little recap of this does all the editor window stuff. This is the spot decider thing of deciding whether a spot on the tic-tac-toe board is blank X or O. This is the custom editor script to do that, which does things as we've explained. This is the saving of the text for all the long pieces of text. This is the scriptable object. This is the way of accessing that scriptable object in the inspector. It's right in the scene view. I keep saying the wrong words. This is a way of having the all the long text in one place. This is a way to access that long text in the scene view, and thus the editor window doing that through the scene view rather than accessing the asset directly, which I wanted. And then this is doing the number for the number guessing game. That is level 5. And then this is the custom property drawer for that also implements some of the functionality for drawing, like the continue button and all that. And that all leads to, in a nutshell, all of the interesting, cool custom editor functionality that we see here. So just a quick, then going back to here, we got the spinning text here. Can you click this? I'm not going to solve all the puzzles now, but like doing the math questions, moving the slider to match a position, playing tic-tac-toe, and guessing a number. This is working. I don't know why this broke like halfway through my explanation, but yeah, it is working. I think it was something of me changing code in the middle of going through it. Anyways, so good that is not actually broken. Setting some toggle switches to turn on and off lights. Typing hello world, or just typing text and seeing what that is. Making buttons match a desired pattern and changing cubes and changing colors. Setting transform stuff and forcefully changing what the inspector is to have one object copy the position, rotation, and scale of another. And a really, really cool maze game. I quite like how this turned out. I think it's neat. A maze game with mock, pseudo, custom collision detection, and then an ending where we also just have a game object that's rotation is moving based on a sine wave. And with all of that, that brings us to the end of, I guess, my explanation on editor madness. So I hope you enjoyed this, I guess. It's the same as what I did before. I'm making all these like smaller Unity projects, and I'm hoping to continue to make these videos just going through explaining how I made them. I think it's interesting to see the kind of behind the scenes of how some of this stuff is made and seeing the kind of how they went from start to finish. Like I was giving my rationale for why I was making certain things and why I did certain things the way that I did them. And yeah, hopefully it was enjoyable to watch. But I guess, that'll do it for, we have that continue to be swaying back and forth. But that'll do it for this thing. Look forward to more development logs of things that I'm also making. The next thing that I'm making, if it goes how I want it to, will be really, really cool. I'm working on a project now that is, coming along really cool. It's really, really cool. You'll see it at some point, a development log on that. That might be one thing where, because it's so big, I might actually do a development log like in the middle of it, not at the end. We'll see. I might change my mind on that, but we'll see. Long story short, it's like a tag thing with a lot of really complicated, cool pathfinding AI to play tag with an AI in a really complicated environment. So that's the long and short of it, but you'll maybe see that at some point when I actually finish it. But Anyways, we'll wrap it up for this project and this video. So I guess all I can say now is thank you all, or no, that's not my outro, getting ahead of myself. That'll do it for this video. If you liked it, look forward to more. Thank you all so much for watching, and as always, I'll see you around.